Okay, so unit 6, we're starting with something called neutralization, and then rxn just means reaction because it kind of sounds like reaction. So we're starting with something called neutralization reactions. Now, we're going to start with two definitions. I'll tell you guys what you guys need to write down, so you guys don't need to write everything. You guys have to write this word down: acids. There are two chemicals we're going to be talking about basically the entire unit until like May. The first is called an acid, and it's not that kind of acid that you guys are thinking about. It's a type of chemical. And acids, what they do is they release H plus into your solution. So if you have a container and you put an acid in there, so let's say this is my container, and then I put acid in it. Okay, the acid is going to produce H plus.
Great try.
Thank you. I should be an artist. Okay, H plus inside of your solution. Okay, so if you guys want to write that acids are H plus donors, that's probably the easiest way to think about it. So an example of an acid is HCl. You put HCl inside of water, it turns into H plus and Cl minus. So if you notice, it's going to increase the amount of H plus inside of your solution. Okay, that's what an acid is. This right here, acids, and then the definition, H plus donor. So it gives H plus. That's the first one, yeah. Super easy. Okay, so that's the first type of compound we'll be talking about. The other kind of compound is called a base, okay? Bases. Okay, and bases, you can kind of think of them as opposites of acids. Okay, and what bases do is they give off OH minus. So they give up Me. They release Me inside of a solution. What's up? No, you don't have to. Just the name acid and then the quick definition. Okay. Okay, so acids, they release H plus, and bases, same thing. If I have a container and I put a base in there, it's going to produce OH minus. Okay. All right, so those are the two definitions for this unit. We're going to do a quick practice problem to see if you guys can identify an acid and base in a reaction. And yeah, and then we'll move on. We have one more problem after that. Any questions, though, on acids and bases? Okay. All right, so what I want you guys to do is I want you guys to just write down this equation real quick. And I want you guys to write down which chemical you think is the acid and which one you think is the base. Quick note before you guys start: acids and bases, they will always be on the left side of the equation only. Okay? Yeah. Okay, so we said earlier that acids they give off H plus inside of a solution, right? So if we take a look at these chemicals, if you take a look at this first one, HCl, this one's gonna be your acid, but we can tell this is the acid because this breaks down into H plus and Cl minus. Okay, do you guys remember us doing that last unit? It releases H plus and Cl minus. So if it releases H plus, there's going to be more H plus, right? So that's why this one right here is going to be your acid. HCl is your acid. Okay. The next chemical, NaOH, if you guys take a look at this chemical, this is going to break down to Na plus and OH minus. Again, it's the same thing that we did last unit. We're just building on top of it. And so since this chemical is going to make more OH minus when you put it into a solution, this is going to be your base. Okay? So very easy way to identify acid and base. Acid is going to break apart into H plus. And a base is going to break apart into OH minus. Okay? So that's how you can tell them apart. And the key thing, if you guys want to jot it down, your acid and your base is always on the left side of the equation. Okay? Okay, so it's only on the left side. Yes.
OH is like 4.
Sorry, what was that?
Like, how do you said like OH has 4, or like with your
sorry, let me repeat myself and tell me if this clarifies. NaOH is the base because it breaks apart into Na, and then OH is the polyatomic, right? Hydroxide on your chart. And so it breaks apart into these two. So if this chemical breaks into OH minus, if I put it into a, into a solution, it's going to break apart into NaOH minus. So if it breaks apart into these two, there's going to be more OH minus, right? And so that's why it's going to be a base. Yeah, that makes sense. Yeah, because the more of these I put in here, the more OH minus it's going to make, right? Like if I put 3, yeah, that makes sense. Okay, for sure. All right, any other questions? Okay, so before we move on to the last thing, I want to talk about the right side of the equation now. Okay, so whenever we mix an acid and a base, it's always going to make the same 2 types of chemicals. The first chemical that you're going to make is, if you guys take a look at this one, HOH. If you rearrange this formula, this is the same thing as H2O, right? You guys notice that? It's 2 H's and an oxygen. And what chemical is H2O? Yeah, water. So that's the first chemical you're always going to make when you mix an acid and a base. The first chemical you're always going to make is called water. And so for this class, you can either write water as H2O or HOH, but they mean the same thing, okay? I recommend doing HOH for this unit just because it'll kind of be easier to write, and I'll show you guys why in just a second. But HOH is the same thing as H2O, which is water, okay? All right, and then the last chemical that you're always going to make, it's called a salt. And it's not the salt that you eat, but basically a salt in chemistry is a chemical that's made up of a positive ion and a negative ion, okay? So a salt is something made out of a positive and negative. So if you guys notice, NaCl is made out of Na plus and Cl minus. So it's made out of a positive and a negative. So it's going to be a salt. Okay, so if you guys notice, this is basically what we've been doing for the past semester. We're just kind of putting some new definitions and things on it. What's up? It's always considered a salt. That's correct. So if I did something like this, Mg2 plus and S2 minus, MgS, this is also considered a type of salt. Okay, so anything made up of a positive and negative. Good question. All right, let's move on to the last problem, and then we'll end for today. So you guys don't need to write this down. We basically talked about this just now. Okay, so on your assignment today, you're going to get problems that look like this. And if you notice, it looks very similar to what we've been doing up until this point, right? So I'm going to give you guys maybe about 3 minutes. I want you guys to see if you guys can finish this problem on your own, okay? For part A, same thing. You got the left side of the equation. I need you guys to figure out what is produced on the right side, and you guys got to balance it. And then see if after that you can finish the acid, base, and salt, okay? So if that part's still confusing, make sure you guys get part A done, because it's pretty much the same types of problem we've been doing for this semester. So try that out, check with your neighbor, and then we'll go over this in 3 minutes, okay? Okay, so we're going to be finishing this equation. So like I said earlier, you're gonna need your periodic table or the solubility chart. I'm gonna use the periodic table just because it'll be a little bit more helpful going forward. But if you guys take a look at hydrogen, it's +1, right? So HBr is going to break down into H plus. And then if you take a look at Br on the periodic table or your solubility table, you'll notice that Br is -1. Okay, so HBr breaks down into H plus and Br minus. Everybody go with that? Okay. The next chemical is BaOH2. So if you take a look at Ba on the periodic table, you'll notice that Ba is right here on the +2 column. Okay, so Ba is going to be +2. Okay, and then OH minus, it's on your polyatomic chart, but at this point, you guys should know that Mr. O is a little bit negative, so it's OH minus. Okay, so BaOH2 breaks down to Ba2 plus and OH minus. Everybody go with that? Okay, so we're going to do the double replacement. So we're going to connect H and OH, and we said earlier that HOH is water, right? So this is your first chemical, water. And then the second one is Ba and Br. So if you put Ba and Br together, does the positive and negative energy balance out? So 2 plus and minus 1, does that balance? Nah. So which one do you need more of? Yeah, BR. You're gonna need a total of 2 BRs in order to balance that out. Okay. So hopefully not too bad. Similar to what we've been doing. It's just double replacement. Okay. Yes. Yeah, so we're gonna balance it right now. You're a little. Oh, sorry. You're gonna want to put the 2 behind because you need 2 BRs to cancel out 1 BA. Because if you notice, it's 2 plus minus 1, so you'll need 2 of these in order to balance out the BA, right? So you need BA and then 2 BRs. The numbers are in the front will be for the balancing, which we'll do it right now. Okay, good question though. All right, we're gonna move on now to the balancing. We want to make sure we have the same number of every chemical on both sides. So in the equation, we have H, we have BR, we have BA, and we have OH. Okay, so we're gonna make a little table, and then we're gonna count up how many we have on both sides. Okay, so I'll do it for you, just to kind of speed things up. You'll get 1 HBr, 1 BA, and 2 OHs. And then on the right side, you have 2 BRs and then 1 of everything else. Okay. All right, so let's take a look at BR because that's the one that's not balanced. Which side needs more BRs, the left side or the right side? Yeah, the left side. So we have to add the whole chemical that BR is a part of. So HBr, that's going to change our numbers for H to 2 and BR to 2. Okay. Everybody good so far? Okay. We got to fix up the H's now. Which side needs more H, the left side or the right side? The right side. Now, if you guys notice, we need more on the right side for H and for OH, right? So we're going to add HOH. We're going to add another water molecule. Okay, that's going to get us to 2 and to 2. And then we're all balanced out. So we just put a 2 right here in front of HBr and a 2 in front of water. Okay, so that's how we do the balancing. Okay, just keep in mind that the H that's a part of OH is not just a regular H, so just keep that in mind. You have to keep them separate when you're counting them. Okay. All right. And then last step, let's identify the acid, the base, and the salt. If we take a look at the acid and the base, we said they're always on the left side of the equation, right? So which chemical here is your acid? Yeah, HBr. Good. Okay, because that's the one that breaks up into H plus. Okay, let's look at the base. Which chemical is your base? Yeah, BaOH2, because that's the one that gives up OH. And then your salt is the one on the right side that's not water. And so it's going to be BaBr2. Okay. Okay, so you can either write it like this, or if you wanted to write it like this, you can write on your equation directly acid, base, salt. I'm cool with that too, as long as you label it in a way that my TAs can read it, okay?